Today's lessons will be on arithmetic, sequences, and series. Our objective is going to be to identify an arithmetic sequence, find an explicit formula for its nth term, and write a recursive formula for them. So first of all, types of sequences and series. So we're looking for a list of numbers which have a certain pattern, and then we will label them and do some more work on them as far as finding specific terms and sums of those series. So for example, this first sequence of 2, 4, 6, 8, a very simple sequence. I'm sure you could tell me right now that the next few terms are 10, 12, 14, and so on. This is going up by 2, where we are adding 2 each time. Therefore, we would call this an arithmetic sequence. The next sequence, 3, 12, 48, if you look closely, they're multiplying by 4. And so therefore, the next term would be whatever 48 times 4 is, which is 192. And then we would multiply that by 4 again, which is 768, and so on. So this one we are multiplying by 4. This would be called a geometric sequence. The next sequence, we've got 15, 12, 9, 6. As you can see, they're going down by 3. So your next terms would be 3, 0, negative 3. And we're just going to stick with adding instead of saying subtract. So basically what we're doing is we're adding a negative 3 to this. This would still be arithmetic. So anytime you're adding something to each term, it's an arithmetic sequence. The next couple sequences are kind of unique and a little more challenging. We've got 3, 7, 15, 31. So if you really look closely at this, the pattern is, it looks like we're doubling the number and we're adding 1. We're doubling it and then adding 1. Okay, this would be a little bit harder to write a formula for, but the next term would be 63, and the next term would be 127, and so on. Don't really have a specific name for this type. The next sequence, 2, 5, 26, 677. Again, a little bit more tricky to find out, but what we're doing is we're squaring the number and then adding 1. For example, 2 squared is 4, plus 1 is 5. 5 squared is 25, plus 1 is 26. 26 squared is 676, plus 1 is 677. And the next term, if we square 677 and we add 1, we'll already be at 458,330. So those are different types of sequences and patterns. There's a whole bunch of them. In this particular lesson, we are going to focus on the arithmetic sequences and series. So an arithmetic sequence as a definition has a common difference. For example, the sequence 2, 6, 10, 14 has a common difference of 4. The sequence 2, 3.2, 4.4, 5.6 has a common difference of 1.2. And the sequence of 3 sevenths, 6 sevenths, 9 sevenths, 12 sevenths has a common difference of 3 sevenths. So it doesn't matter whether we're dealing with integers, with fractions, with decimals, an arithmetic sequence has a common difference. Now, to write a formula for an explicit formula for an arithmetic sequence, the formula is to find any term, and this a sub n stands for the nth term, stands for any term. We would take the first term, a sub 1, that's the first term, and we would add that common difference n minus 1 times. So if you think about that, if you're finding the second term of a sequence, you're going to add that number 1 time. If you're going to find the third term, you're going to add it 2 times, and so on. Or a trick to this is to write the formula as a sub n equals d times n, the difference times n, plus the 0 term. This would be the term before the first term. All right, so for example, if I have this arithmetic sequence, let's say I've got 3, 9, 15, 21. The formula for the nth term, using the first formula, would be the first term, 3, plus the difference, 6, times n minus 1. Using kind of the trick, the nth term would equal 6 times n, plus the 0 term, the term before the first one, would be a negative 3. Okay, why are these forms important? Let's say I ask you to find the 10th term of the sequence. We would just put 10 in for n. So here we would take 10 minus 1, which is 9. 6 times 9 is 54, plus 3 is 57. If I did that in this next one, I have 6 times 10, which is 60, plus a negative 3 is also 57. So some more examples of arithmetic sequences. 5, 9, 13, 17. This one has a difference of 4. So formulas for this would be a sub n, I'm going to use a lowercase a here, but it doesn't matter, would be first term plus the difference times n minus 1. Now you could distribute that 4, combine like terms, and we'd have 4n plus 1. Using that little trick we talked about before, this would be the difference times n. And then your term before the first would be a positive 1. So you can see you get the same formula in both cases there. Next one has a common difference of, I got a little mistake here. We're subtracting 6. This should be a negative 7. I apologize for that. Write this date down. Mr. Arnoli made another mistake. But the difference should be negative 6 in this case. So then our formula would be first term, 5, minus the 6 times n minus 1. Or, using the other method, it'd be negative 6 times n. And then the term before the first would be 11. Let's say I asked you to find the 12th term of the sequence. You'd put 12 in for n. And in both of these cases, you would get, bear with me here a second. So I'm taking negative 6 times 12 and I'm adding 11, which would be negative 61, which seems to make sense there. This next one looks like it has a common difference of 1.4. So this formula, if I just use that shortcut, which I like to do for arithmetic, it'd be 1.4 times n, plus that term before the first one would be 3.1. And so if I was asked to find the 15th term, I would just plug 15 in for n. Take 1.4 times 15 and add 3.1. So these are examples as far as how to find a specific term of an arithmetic sequence. There will be another short video here dealing with recursive formulas and how to find the sum of arithmetic series.